What's going on, everybody? We are beginning chapter 10. Chapter 10 is on probability. Honestly, this is a chapter that gets skipped over a lot because it ends up being at the end of the year. I really like it, but I think probability is super important. If you think about it, that's kind of how we live every day, right? There's always a probability of something going to be happening. So I always like to do this chapter, even though a lot of times it gets skipped. Okay, the notes and the slides are up in Canvas. Make sure you're following along and writing your own notes. Okay, so examples, all right, what is the probability of a tails in a coin flip? What is the probability of rolling a 3 on a dice? What is the probability of rolling a 7 on a dice, right? These are things that we can just do basic examples of when we're thinking about probability. Okay, so probability, the definition is the probability of an event is the likeliness or chance that an event will occur. Probability is shown as a number between 0 and 1 and can be written as a decimal, a fraction, or a percent. I would say that most of the time you end up seeing it as a fraction or as a percent, not so often as a decimal, but you can technically write it that way. All right, so probability is always a number between 0 and 1. Okay, and if we take a look at our spectrum, right, like we said, any number between 0 and 1, if the probability is 0, that means it's impossible. It cannot ever happen, right? Absolutely zero chance. Probability of the sun rotating around the earth is 0. Probability of 0.5, that's equally likely to happen or to not happen. For example, like a coin flip, you got 1 out of 2 options, right? It can be heads, it can be tails, you got a 50-50 chance. If the probability is 1, that means it's certain. Absolutely will happen always, no matter what. So if we flip-flop the example of probability of 0, a probability of 1 would be the earth rotates around the sun. That does happen every single day, every single time, no matter what. Anywhere if it's in between 0 and 0.5, that makes it unlikely, and anywhere in between 0.5 and 1 makes it likely. Notice the difference of in between versus 0.25 and 0.75 shown on the graph. All right, on this graph, in this picture, it says that unlikely is at 0.25 and likely is at 0.75. But remember, it's in between. So anywhere between 0 and 0.5 is unlikely. Anywhere between 0.5 and 1 is likely. Okay, so think about the spectrum now. Probability that it will snow in Mission Viejo. I would say that it's probably unlikely, right? It doesn't happen very often. It can happen. Probably you will get tails in a coin flip, right? 0.5, equally likely. Probability that you will roll 3 on a dice. Well, an irregular dice or die has 6 outcomes. 1 out of 6 outcomes probably means it's going to be unlikely. Probability that the earth rotates around the sun, again, I already used that example, but that is 1. That is certain, 100%. You have a bag of marbles, 10 green and 2 red. Probability that you will reach in and take out a green marble, well, 10, and there's only 2 red. That's probably pretty likely in this likely area somewhere. Okay, so there's 2 types of probability. Theoretical probability is the probability that we typically think about. And like I said, it's usually written as a fraction, and we can turn that fraction into a decimal or a percent. But the theoretical probability is the number of favorable outcomes over, right, that's a fraction, over the total number of outcomes. So the thing that we want to happen over the total things that can happen. Right, so if we think about some examples, we've already talked, what is the probability of tails in a coin flip? Well, there is only 1 tails on a coin, and there are 2 outcomes. Sorry, I wrote that really big. All right, so there's 2 outcomes, heads or tails, so that means it's 1/2. If we wanted to write it as a fraction, or that is a fraction. If we wanted to write it as a decimal, that's 0.5. If we wanted to write it as a percentage, that's 50%. What is the probability of rolling a 3 on a dice? Well, like I said, there's only 1 3 on a dice, and there are 6 numbers on a dice. So that means it's 1/6, right? Again, if you wanted to, you could write that as a decimal, or you could write that as a percentage. So if I wanted to do that, to transfer a fraction to a decimal, 1 divided by 6 comes out to 0.166 repeated. And then if I wanted to change that to a percentage, that would be about 16.6%. Okay, what is the probability of rolling a 7 on a dice? Well, that would be 0 out of 6. It would be 0.0, and it would be a 0% because there are no 7s on a dice. If you're rolling just 1 dice or die, there is no 7, so that would be a 0. Experimental probability is the number of successes out of the number of trials, right? So the example that I usually go with experimental probability is the coin flip. We know that the theoretical should be 1 out of 2, right? That means 50% of the time you should get heads and 50% of the time you should get tails, right? But when you actually do it in real life, that doesn't always happen. So that's why we have experimental probability as well, right? And this is an example here. You flip a coin 20 times, 17 times you flipped heads and 3 times you flipped tails. What is the experimental probability of flipping heads, right? So that means experimental probability of flipping heads. We flipped heads 17 out of 20, right? And that is the experimental, right? The theoretical should be just 1 over 2, right? Does it match the theoretical probability? Is it higher or is it lower? So if we experimented and we got 17 out of 20, theoretically, we should have gotten 10 out of 20, right? Because 10 out of 20 is the same thing as 1/2, which means that this experimental probability is higher than the theoretical probability. That's why you have to make sure that there's a difference, because we know what should happen, but that doesn't always happen. Okay, independent versus dependent. Independent means it's not reliant on what happens previously, right? Think if you're an independent person, you don't rely on other people. One event does not affect the other. A dependent event is reliant on what happens previously. One event does affect the other. Okay. We're going to take some examples and take a look at what that actually means, right? So finding a probability of multiple events, multiply the 2 separate probabilities. And again, remember to make sure that you change the numbers if the events are dependent. Okay, so if we take a look, right? As part of a board game, you need to spin the spinner at the over here, right? Which is divided into equal parts. Find the probability that you get 25 on your first spin and 50 on your second spin. So first, we need to think, right? Is it dependent or independent? If I do this spinner once, does my result of the first spin impact what happens on the second spin? And the correct answer would be no, right? So these would be independent. Whatever you get on the first one does not have an impact on what you're going to get on the second one, because they're all equal, right? It's all going to be the same. So to find both of these, you have to find the probability of getting a 25. We see that there are 2 25s out of how many? 1, 2, 3, 4, 5, 6, 7, 8, right? 2 25s out of 8 possibilities. And then we multiply that by our probability of getting a 50. And we see there's only 1 50 out of the 8. So we'd multiply that, right? And then when you multiply fractions, you just go straight across. 2 times 1 becomes 2. 8 times 8 becomes 64. That means the probability of getting a 25 on your first spin and then a 50 on your second spin is 2 out of 64. If you want to, you can simplify 1 out of 32. That means we would have to do that 32 times, and we should theoretically get it only once, right? So that's pretty low probability, right? But that's how you do 2 separate ones. You multiply them together, and they're independent because they don't rely on each other. So another example, a bowl contains 36 green grapes and 14 purple grapes. You randomly choose a grape and eat it, randomly choose another grape. Find the probability that both events A and B will occur. A is the first grape is green and B is the second grape is green. So now we have to decide, is it dependent or independent? All right, what tells us, it gives us the answer, is that you eat the grape. So after you take one of the grapes out, you eat it. So then when you go back to pick a second grape, your number of grapes has changed, right? So if we think, so the answer here is dependent. It's dependent because if we think we have 36 green plus the 14 purple, which means we have in the beginning a total of 50 grapes, right? But once you take one and eat one, that means the next time you're only going to have 49 grapes, which means that your event is dependent because the numbers have changed. So if our 2 events is first grape is green, right? If we get 30, there's 36 out of 50. But if we get the green grape, that means one of the green grapes is gone. So that means there's 35. And then just one of the grapes of total is gone. So it drops down to 49. So that's why it's dependent, because these numbers change depending on what happened the first time. But they're still 2 separate events. So that means we multiply them together, right? These are going to be big numbers. When you multiply fractions, like I said, you just go straight across. So that means 36 times 35 gives us 1260 over 50 times 49. That gives us 2450, All right, so that's the probability. You can simplify that fraction. When they're really, really big fractions, I'm not gonna have you simplify them. When they are smaller, I would like you to try and simplify them. You'll see that on your homework that you're doing here as well. Okay, and then if we wanted to turn that into a percentage, we just divide it. 1260 divided by 2450. That gives us a decimal of 0.514. Or we can change that to a percentage of about 51.4%. Right, so that's the probability, that's the probability, that's the probability, and that's the probability. They're all three the same probability, and we know that they're dependent because they rely on what happens first. Okay, probability versus odds. So probability is the favorable outcome over the total outcome. Now, when we're talking about odds, that's the odds of an event compared to the number of favorable versus unfavorable outcomes when all outcomes are equally likely. So odds in favor would be favorable outcomes over unfavorable outcomes, and odds against means unfavorable outcomes over favorable outcomes. Notice, for when you're doing odds, you're never going to have the total outcome. You're just going to have what you want versus what you don't want, right? That's the difference between odds and probability. Okay, so now if we're talking about odds, what are the odds in favor of landing on an even number? So let's go through and find all of our even numbers. That's even, even, even. So we have 1, 2, 3, 4, 5, 6, right? Odds in favor, there's 6 favorable outcomes over, if I use a different color, what are the unfavorable? All right, that's odd, that's odd, that's odd, and that's odd. So 6 favorable over 4 unfavorable. Now this, I would totally expect you to simplify. We can divide both of these by 2, and that would come out to 3 halves, right? So that means if 3 halves is bigger than 1, that means the odds are in favor of landing on an even number. What are the odds against landing on a number higher than 10? Well, against, that means we want unfavorable on top and favorable on bottom. So if I erase all of these lines here, we want the unfavorable to be on top. So unfavorable is any number lower than 10, which we see we have 1, 2, 3, right? So 3 unfavorable over, that means the rest of them, 1, 2, 3, 4, 5, 6, 7, would be favorable. That would be 3 7ths. Okay, and that one can't be simplified. Now, what is the probability of landing on a multiple of 2? Which ones can be multiplied by 2? So this one, we want favorable over total because it's probability and not odds. So that means we got to go through and pick the numbers that can be divided by 2. That can, cannot, yes, no, yes, no, yes, no, yes. So 1, 2, 3, 4, 5, 6. There are 6 numbers that can be divided by 2 over. Now, since it's probability, it's over the total, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 6 over 10. And again, this one I would expect you to simplify. You can divide both of those by 2. 6 divided by 2 gives you 3. 10 divided by 2 gives you 5, right? So 3/5. That is the difference between probability and odds in favor and odds against. Okay, and that's all that I have. This chapter 10, is going to be really short. It's just going to be 2 lessons. Like I said, we're going to keep things pretty basic, but I enjoy this chapter. I hope you have a good time as well. Go Mustangs.